What if a single paradox could reveal that our universe is just one of many? In the world of quantum physics, this question isn't science fiction. It's one of the most serious, most debated mysteries in modern science. And it starts with something that seems simple, but isn't: the act of observation. In the quantum world, particles don't have fixed properties. They exist in multiple states at once, what physicists call superposition. An electron can spin both up and down. A photon can take multiple paths simultaneously. But here's the twist. The moment we observe one of these particles, the moment we try to measure it, the superposition collapses. The particle chooses one path, one spin, one outcome. Why does that happen? It's called the quantum measurement problem, and it shakes the foundations of reality. To understand how deep this goes, consider the double-slit experiment. When we fire single electrons at a wall with two slits, they don't just go through one or the other. They create an interference pattern, as if each electron went through both slits at once, behaving like a wave. But place a detector to observe which slit the electron passes through, and the interference pattern disappears. Now the electron acts like a particle. One slit, one path. So what changed? Just the act of looking. It's as if reality only becomes real when we watch it. To explain this, one theory goes far beyond anything classical physics could imagine. It's called the many worlds interpretation. Instead of a wave function collapsing into one outcome, every possible outcome happens. Each result unfolds in a separate branch of the universe. You saw the electron pass through the left slit. Somewhere else, in another universe, another version of you saw it go through the right. This theory was proposed by physicist Hugh Everett in 1957. At the time, most of the scientific community dismissed it. But over the decades, many worlds began to gain traction. Not just because it's bold, but because it makes the math work. It avoids collapse. It preserves information. It keeps quantum mechanics clean, elegant, and incredibly strange. If it's true, it means that right now there are countless versions of you, living out every possible outcome of every possible quantum event. And this leads to a mind-breaking paradox, one that just might prove parallel universes are real. Let's return to the double-slit experiment. Every time we fire an electron and observe one result, we assume the other possibilities simply vanish. But in quantum mechanics, there's a rule that cannot be broken. Information cannot be destroyed. So, what happens to the path the electron didn't take? If we accept the many worlds interpretation, the answer is clear. It still happened, in a parallel universe. One where the electron chose the other path and another version of you saw it. Each quantum choice branches reality. Each possibility becomes a real universe. This isn't fantasy. It's what the math demands if we remove wave function collapse from the equation. And here's where it gets even stranger. In 2018, physicists Daniela Fraukiger and Renato Renner published a thought experiment. It showed that if quantum mechanics applies to observers as well as particles, then different observers could come to logically inconsistent conclusions unless multiple realities exist. This isn't a fringe idea. It's a serious challenge to the way we understand measurement, reality, and truth itself. Then there's decoherence, a key concept that helps explain why we don't see other universes. In quantum theory, when a particle is in superposition, it exists in all states. But once it interacts with the environment, with air molecules, photons, or us, that superposition quickly decoheres. The different outcomes no longer interfere. They become separate, classical, invisible. From our perspective, only one outcome survives. But in the math, nothing disappears. The other outcomes just become inaccessible, like pages torn from a book we can't read, but that still exists somewhere in the library. So why don't we feel the universe splitting? Because decoherence hides it from us. The process is so fast, so complete, that we never notice the transition. But just because we can't see the split doesn't mean it didn't happen. Which brings us to a terrifying, beautiful idea, that every choice you make, Every hesitation, every action creates a new version of you in a new world. In one universe, you're watching this video. In another, you never clicked play. And the implications don't stop at particles or decisions. They ripple out into the very structure of the cosmos. In the next part, we'll explore how black holes, cosmic inflation, and the early moments after the Big Bang all seem to point toward a multiverse. Not as theory, but as the most logical outcome of physics itself. Let's zoom out, far beyond atoms and electrons, to the largest structures in the cosmos. Because surprisingly, the idea of parallel universes doesn't just come from the quantum world. It also emerges from our best theories about how the universe began. According to the theory of cosmic inflation, the universe expanded faster than the speed of light just moments after the Big Bang. This sudden burst stretched space itself, smoothing out irregularities and explaining why the universe appears so uniform today. But here's the twist. Inflation never really stops. In most versions of the theory, while our region of the universe cooled and formed stars and galaxies, other regions kept inflating. They became separate bubbles of space, each potentially forming their own universe, with different laws of physics, different particles, even different dimensions. This is the inflationary multiverse, a vast sea of bubble universes all born from the same expanding fabric of space, but each evolving in its own way. And according to some physicists, we may already have seen traces of them. Tiny anomalies in the cosmic microwave background, the afterglow of the Big Bang, might be evidence of a collision between our universe and another. Nothing has been confirmed yet, but the idea that other universes could leave scars on our sky isn't science fiction. It's an active area of research. Now let's go even deeper, into black holes. These are the most extreme objects in the universe, regions where gravity is so strong that not even light can escape. And yet black holes pose a paradox. According to quantum physics, information can never be lost. But if something falls into a black hole, and the black hole eventually evaporates, where does the information go? This is known as the black hole information paradox, one of the greatest unsolved puzzles in modern physics. One proposed solution: that black holes don't destroy information, they transfer it, maybe even to another universe. In some theories, black holes could act like tunnels, bridges through space-time that connect our universe to another. Matter and energy might fall into one side and emerge in a parallel reality. If that's true, then every black hole might be a portal to a new universe. It sounds incredible, but the equations don't rule it out. And it's not just black holes. Quantum entanglement, the mysterious connection between particles, may also hint at links between universes. When two particles are entangled, a change in one instantly affects the other, no matter the distance. Einstein called it spooky action at a distance. But what if entanglement isn't just a connection across space? What if it's a connection across realities? Some physicists now think that wormholes, hypothetical tunnels through space-time, might actually be the physical manifestation of entangled particles. A bridge not just across space, but between worlds. If true, this could be the key to understanding how multiple universes stay connected, even if we can't see them. In the final part, we'll go beyond the science, into the philosophical and personal implications of living in a multiverse. Because if every version of you exists somewhere, then who are you really? And what does it mean to choose when every possible choice already exists? So far, we've explored quantum paradoxes, cosmic inflation, black holes, and entanglement, all pointing toward the same radical idea, that our universe might not be alone. But now we arrive at a deeper mystery. If all these parallel universes exist, why are we in this one? And why are we only aware of a single thread of reality? This brings us to a concept at the frontier of both physics and philosophy: consciousness. In some interpretations of quantum mechanics, consciousness plays a vital role in selecting which outcome becomes real. Not just observing, but collapsing possibility into experience. According to this view, your awareness is not passive. It's the filter that locks one version of reality into focus out of countless others. It's like a cosmic lens, narrowing the infinite branches of the multiverse into a single, continuous narrative. The one you call your life. That means every choice, every thought, every observation could be guiding you along a unique trajectory. One version of reality shaped by you, yet always entangled with the others. Now imagine this. You stand at a crossroads in life. You choose left instead of right. In another universe, a version of you chose the opposite. That path exists. That version of you exists. And yet you'll never meet them. It's not science fiction. It's a consequence of quantum math, and perhaps the structure of consciousness itself. Some physicists even propose that consciousness might be quantum in nature, operating through processes in the brain that allow for superposition, entanglement, and even branching realities. It's speculative, but if true, it would mean that our very awareness is tied to the multiverse. That your mind isn't just navigating one world, it's selecting one path among infinite. And that brings us to the most human question of all. If every possible outcome already exists, do our choices still matter? Does free will exist? Or are we passengers on a train that splits endlessly, forever out of our control? Here's one way to look at it. Even if all outcomes happen, you are only aware of one. And that awareness, that experience is real. You still choose. You still feel. You still suffer, hope, love, and act with purpose. In that sense, your reality matters, because it's the one you live. You're not lost in the multiverse. You're anchored in it, through the experience of being you. So maybe the paradox isn't that everything happens. Maybe the paradox is that only one version feels real. And maybe that's what gives your choices meaning. Not because they stop other realities from existing, but because they define the one you inhabit. To fully grasp how deep the multiverse might go, we need to challenge one final assumption, that time flows in a single direction. Because just like space can split into branches, some theories suggest that time itself might be more flexible than we imagine. In classical physics, time is linear, past, present, future. But in relativity, time is relative. It stretches, bends, slows down, depending on speed, gravity, and perspective. And in quantum physics, time starts to lose all meaning. There are interpretations where time isn't a fundamental property of the universe, but an emergent phenomenon. In other words, time is something that appears only when consciousness observes change. What if all moments already exist? Not as a flowing river, but as a static landscape, and consciousness is simply moving through it, one frame at a time. Like reading a book, page by page, but the entire story already exists, beginning, middle, and end. Now imagine this across parallel universes. Each branch of the multiverse is like a different book, a different path, a different story. And you, the reader, only experience one narrative, unaware of the infinite other books on the shelf. But the library is real. Every possible version of events stored in a timeless archive of possibility. And then we must ask, if all these versions exist, are they still you, or are they strangers who just happen to share your face? This question forces us to confront the nature of identity. Is your identity defined by your choices, your memories, your continuity? If so, then every version of you is valid, because every version made real choices, felt real things, and lived a real life. But what connects them? Some physicists, and even philosophers, believe there might be a core pattern, a kind of meta-self that flows through all versions. Not the same experiences, not the same personality, but the same fundamental spark of awareness. That spark could be the true constant, the thread that ties together every version of you, across every universe, every outcome, every timeline. So maybe the self is not a fixed point, but a trajectory. Not a destination, but a direction. You are not one version of yourself. You are the sum of all your possibilities. And here's where science meets something deeper. If infinite versions of you exist, and if your awareness is the thread that experiences only one at a time, then maybe the greatest power you have is to shape the version you inhabit through intention, through imagination, through choice. You may not control the multiverse, but you can navigate it by aligning with the path that feels most meaningful. And in doing so, you give this version of you its purpose. Because out of all the infinite versions of reality, you're living this one, right now. And maybe that means more than we'll ever understand. So where does that leave us? With infinite versions of you, infinite outcomes, infinite universes, but only one that you're aware of, this one. And maybe, just maybe, that makes it sacred. You could have been anyone. You could have lived 1,000 other lives. But right now you're here, breathing, thinking, wondering. That's not an accident. That's the miracle. Because in a multiverse of endless paths, you chose this one. Or maybe it chose you. And what you do with it still matters. Not because it changes all the other universes, but because it defines this one. So keep asking questions. Keep imagining what's possible. Keep moving forward, even when the path isn't clear. Because curiosity isn't just a human trait. It might be the one constant across all realities. And maybe that's what makes us special. Not our certainty, but our search. Not our answers, but our willingness to ask. And that, in any universe, is where true meaning begins. Because what if this question, is this the only universe, is just the beginning? What if, somewhere out there, another version of you is asking the very same thing, right now? And what if, just for a moment, you both looked up at the stars at the same time and wondered, what if this isn't everything? Maybe the veil between worlds is thinner than we think. Maybe the next discovery won't come from a telescope or a collider, but from a single idea powerful enough to break through dimensions. And when it comes, will we be ready to see just how far the universe truly goes? Because the real paradox isn't that parallel worlds might exist. It's that we've only just begun to imagine them.